Welcome to our three-part webinar series on ArcGIS Pro for Intelligence. This is part 2 of the series entitled ArcGIS Pro Intelligence for Investigative Support. My name is Carl Walter. I'm the Director of Homeland Security Solutions here at Esri, and I'll be facilitating today's session. Also participating in this webinar are the following folks from Esri. We have James Jones and Tony Angel. Both are product engineers, and from the government side joining us is Jared Bostic. And Jared is the Deputy GIO for the state of Alabama. And within that role as Deputy GIO, Jared is also the GIS lead for the Alabama Fusion Center. And the AFC is one of 80 DHS designated Intel Fusion Centers around the country, all of which sprung up shortly after 9/11. Our agenda today is pretty simple. We're going to start off with the core component of today's webinar, which will be a series of technical vignettes on Pro Intel capabilities that will include data preparation, incident analysis, understanding movement data, and some techniques on how to use cell phone data. Again, our session is titled Pro Intel for Investigative Support, and our vignettes are designed to align with potential investigative techniques, and the workflows we demonstrate will hopefully give you folks ideas on how to leverage Pro Intel for your investigations. Following the technical demos, Tony, Angel, and I will host a short roundtable discussion with Jared Bostic, and we'll focus on questions that might shed some light on how he operationalizes data today for investigations and some tactics that he might deploy using Pro Intel into the future. And after our short roundtable, we'll spend 5 to 10 minutes of Q&A, depending on the amount of questions you folks submit and how much time we have left. And after Q&A, we'll close out and you'll be directed to an online survey that we hope you folks will take the time to complete. And that's our agenda. Let's get started now with our technical demonstrations, and I'll turn things over to Tony and James.
Thank you. Today, what we're going to talk about is using ArcGIS Pro Intelligence to support investigations. And we're going to cover quite a bit of different topics, and this is going to be a very demo-heavy session that we have for you all today. So with that, we're just going to go ahead and start with just kind of some of the things that we're actually going to talk about today. So what we're going to talk about today is we're going to first start off with exploring and cleaning your data. That's always the first step, and it's always the most challenging step. And there's a lot of different ways that you can do that inside of ArcGIS Pro Intelligence. And we'll walk you through some of the ways, some of the new ways that have come out in the most recent release of ArcGIS Pro Intelligence. And then from there, what we'll move on to is the analyzing incident patterns and the various tools that help you do that. Next, we'll talk a little bit more about analyzing movement data, what movement data is, and how you can use that to further your investigations and get insight that was previously difficult to ascertain. And then finally, we'll talk a little bit about exploiting cellular data and some of the tools that are available for that. So let's start off with exploring and cleaning your data. So we do have a variety of import options available within ArcGIS Pro Intelligence. Everything from the most basic XY table to point to batch import. And one of the things that was actually introduced at 2.8 was the Big Data Connection Wizard, which actually is very useful if you have a lot of data sitting in flat files on your hard drive or something along those lines. That are similar. Say you have a folder full of CSVs and it's all the crime incidents, and you have it broken out by month or year, and it all shares the same scheme and everything else like that. What you can actually do with the Big Data Connection is use that to just point to the folder, and it will create a layer that's usable within ArcGIS Pro Intelligence across the board. And you don't actually have to do any of the imports. You can specify the geometries, you can specify the time, everything else, and it works natively. It's a fantastic tool. Batch import is also another one of those tools that we maintain that really makes it easy to just point that tool at, say, a directory or something like that, and it just scans through it and it brings in all the different data types that are in there that could be useful and usable. Whenever you have to explore your data, there is a variety of options. We have a lot of different chart options, but probably one of the most exciting is actually the new data engineering view. This was released at 2.8, And essentially what this allows you to do is allows you to visually explore and understand your data before you get into your analysis. It also allows you to do some cleanings and some formatting of your data, which will be useful in a minute whenever we talk about some of the different ways of cleaning your data. And essentially what it does is it really allows you to kind of understand the breakout of your data, some of the summary statistics that come with that. And it's really, really helpful and really useful. And then finally, one of the last things is always the process of data kind of cleaning, the manipulation and bringing all that data into a format that's really usable. Oftentimes, the biggest thing is date time fields that are not in date time field formats, i.e. they could be in strings or text fields. They could be stored as numbers or integers or anything else along those lines. And it really makes doing your follow-on analysis a little bit more difficult. So what we'll do is we'll show you some tools that allow you to do that. One of the big ones is the convert time field, which allows you to essentially just specify the format that your current data is in, whether it's text or something else. Provide that format, and then it will convert that into a date field that you can actually then use in your analysis. Whenever we're talking about analyzing incident patterns, we have a variety of tools. ArcGIS Pro Intelligence has over 1,600 tools available at your disposal to really help understand and do anything you need to do to analyze these patterns and incidents. But I want to really focus on some of these kind of key ones, and those are the spatial statistic tools that are produced. And there's kind of three big ones that I really want to kind of talk about here. And the first one is going to be that density-based clustering. And really what this allows you to do is find and identify any statistically relevant clusters that might exist. And it actually has three different ways of doing it. One of those is through the DB-scan algorithm, another one's through the HDB-scan algorithm, another one, and the final one's through what's known as optics. And these are just different ways of processing your data to understand the statistical significance of any clusters that might exist. Really useful because it is a mathematical approach to really pull data out and kind of help verify what you're seeing visually with, solid data analysis techniques to back it up. Both optimized hotspot and find space-time matches are also incredibly useful in this, and it really helps you understand the larger trends and patterns that might be happening inside there, especially with optimized hotspot. What that allows you to do is determine whether or not incidents in specific areas are getting quote unquote hotter or colder, i.e. are the amount of incidents over the defined time period increasing or are they decreasing? Things along those lines. We also have, something that is super basic but could be incredibly useful is the ability to apply definition queries and just kind of visually explore your data that way. Say you just want to have, you want to take a look at a crime data set, which we'll do here in a couple minutes, and you just want to take a look at the burglaries or the robberies. Or what we'll do later on is we're going to explore all the different arsons that are going on in and around Washington, D.C. And then finally, one of the last things that's really helpful for analyzing incident patterns is exploring everything inside of a timeline, because ArcGIS Pro Intelligence, everyone takes a look at that, and what they see natively is the map, because we're a map-based application. Well, sometimes the patterns that we're most interested in are the temporal patterns. And what the timeline does is it allows us to lay that out and visualize all those points chronologically and how they're interacting with each other in time. So we can explore that and understand that a little bit better. Next, we'll be talking about movement data analysis. Movement data analysis, these movement tools were actually introduced in 2.6, so they're fairly new. We currently have 4 tools. And these allow you to identify and understand how events or these tracks, what we call tracks, are interacting in both space and time. So what we define as a track is any sort of data that has a geometry, a timestamp, and some sort of unique track identifier. And you can get it from a variety of providers. It can be everything from GPS data. Think of the variety of different types of GPS data. Ankle bracelets, cell phone data providers like the mobile marketing data, um, or anything else. And we built these tools to kind of help understand and analyze the patterns that are just naturally present inside those data. Because the big thing with these data sets that makes it difficult to analyze is that there's usually a ton of data inside of movement data sets, and it becomes very difficult to analyze these things. So what we did is we built these off of native big data technology that's already present in Pro, and we built these tools to help conduct that analysis. And there's 4 tools. Classified movement events. Classified movement events allows you to kind of just understand how individual tracks are moving throughout the environment, whether or not they're turning, accelerating, so on. Compare areas. It allows you to have defined areas of interest and allows you to identify what tracks are present inside of those areas of interest and whether or not they're in those areas of interest within a specified time window. Find co-travelers allows you to identify who is traveling together in both space and time. So you can set a defined distance boundary and a time boundary. And if individuals are traveling together and they consistently are within 100 feet and 10 seconds of each other, they're assumed to be co-traveling. So this tool helps you identify those. And then finally, find meeting locations allows us to identify where tracks are dwelling in close spatial and temporal proximity to one another. And I do want to kind of touch upon one last thing for this. The outputs for all of these movement tools are really optimized for visualization inside of that link chart. And what do I mean by that is, it does have the feature class output, which is useful, but the link chart is what really allows you to explore these relationships inside this output data set. And we'll show you how to build link charts off of this movement data here in a couple minutes. And then finally, we'll talk a little bit about exploiting cellular data. So the big provider, the cellular analysis tools, is coming from our crime analysis and safety tools, which is a native part of ArcGIS Pro Intelligence. And we actually have a couple of important conversion tools that exist out there. We can see those there. And really what these tools do is help us import, analyze, and find those necessary patterns that are existing inside those cellular data records, and helps us get to a point where we can find the necessary piece of information that really helps tie an investigation together. And with that, I'm going to go ahead and switch over, and let's go ahead and start showing how some of these tools can be used to really help further support these investigations. So let's jump right in and start understanding how you can use ArcGIS Pro Intelligence to really support various types of investigations. So today what we're going to be doing is we're going to be taking a look at a recent little simulated arson spree in the Washington, D.C. metro area. So we have a kind of a, over the course of a night, we had 2 arsons that occurred, and what we want to do is just really understand the patterns that led to that, and hopefully identify some things that we can then pass on over to one of our colleagues, Tony, who is going to do some follow-on analysis to really help identify maybe who was doing these arsons. So as you can tell, we only have we have 3 arsons here, but these 2 right here really represent our most recent arson events. Uh, and what I have is all the crime incidents from 2021 for Washington, D.C. And I got this from the DC Open Data site. Um, and really what it is just, it's pretty simple. Whenever you open it up, it's just, standard crime data that you might see from anywhere. Um, Pretty basic. But right now it's inside of a CSV. Let's go ahead and bring this in, and we're going to convert this. So since it's inside of a CSV and we already have a lat long field, I'm just going to use the most basic display XY data. In this case, the tool automatically picked it up as far as the longitude and the latitude fields, put them in the correct place. Let's go ahead and give this a good name. We'll just go ahead and call this crime incidents, and we will import this. And this will take about a minute to run. Let that do its thing, and it's going to go ahead and automatically add it to the map. So now that we have this inside the map, what we want to do is we want to go ahead and start exploring this data and understanding kind of some of the different aspects that we can pull out from it. And the way that we're going to do that is we're going to be using the new data engineering view. And in order to access that, the easiest way is to just right click on your layer. And then right here underneath the attribute table is this new data engineering view. You can just select that, and a new view opens up, and it even has a new tab that comes up here. So what we can do is we can start bringing in some things like our report date, the offense, maybe even the shift. And then once we bring all those in, we're just going to calculate it. So one of the nice things that it does is it goes ahead and tells you what type of field it is. In this case, what we've seen is our report date is actually not in a date field, it's in a text field. So we're going to have to fix that, and we're going to have to convert that into a date field so that we can actually analyze this over time. Our shift and our fence are both in text fields as well. But let's take a look at some of the items that exist inside of here. So as far as our fences go, we have kind of a breakdown of all the different crimes. As you can see, our most common is going to be thefts, and actually the interesting thing is, and the least common, is arson. So the fact that we had 2 in one night is interesting in and of itself. So one thing that we can do is inside this data engineering view, we can actually create a chart directly from one of these little previews. All we have to do is just right click on that and just hit open the bar chart. And one of the nice things that data engineering does is, based on the field type that it has, it will go ahead and kind of select an optimal chart presentation for you. So as you can see, whenever we created that chart, yet again, all I did was just right click, hit open bar chart, and it goes ahead and creates the chart itself. So inside of our data set, we only have one previous arson outside of our 2 new ones that have existed. And then we have all of our other events. So that's pretty interesting. So let's jump back to our data engineering view, and let's go ahead and see if we can go and fix the report date field and turn that into a date column. So in order to do that, what we're going to do is go up here to format. And one of the nice things about it is it exposes the convert time field as just a simple tool that exists up there. And all we have to do is just click on that. And it already puts in the input table. And then we just select the field. In this case, it's going to be report date. And then say we want to examine how that field is actually laid out, because we don't have that memorized, and we just want to match it. So in this case, we just have essentially some pretty simple ways to match it, and then we want to give it a good name. In this case, looks like the field got cut off up there. So what we'll do is we'll just call this report date with the E on the end, and then we'll hit OK and let this run. Okay, now that that's done, let's jump back into our data engineering view, and let's go down here to the bottom, and it has our new field down here. So let's go ahead and drag that in there. And we'll go ahead and calculate it. So notice that it gives us a different chart view, and then it also gives us some additional statistics. So it gives us the minimum, which the first event was shortly after midnight on January 1st, the maximum, which is May 4th, and then some other kind of basic statistics as well. Notice how the chart in the chart preview is slightly different as well. We can go ahead and right click on this and go ahead and open up that line chart, and we can just kind of visualize that as well. And we can kind of see the periodicity of what's kind of going on there as well. So one of the other things that might be useful is we can go ahead and inside of this crime incident data, we can go ahead and split this out. And let's just say we want to build some definition queries, and we just want to look at the arsons that already exist inside of here. So in order to do that, we're just going to right click, go down here to build definition query, and let's just go ahead and say we just want to select all of the arsons. Okay, we just hit apply, and let's just go ahead and name this one as arson. And hit OK. So we only have one other arson, and that's sitting over here, kind of on the opposite side of this river. Now, let's say we want to compare this to a different crime type that might exist outside of there. One way that we could do that is we can just go ahead and open up and build another definition query. In this case, let's just say that we want to select, this time we'll select burglaries. Okay. We can go ahead and close out of our charts down here in the table. And then one of the nice things that I really like is the ability to kind of quickly switch between definition queries. The way that you can access that is you can go up to the feature layer, go to the data tab, and you can switch your definition query here between arson and our other query. So here's all of our burglaries, and compare that to our arsons. We notice that burglaries are pretty well spread out throughout the city, while arsons are only limited to one. So we really can't gain a pattern from that one arson. And we can even just go ahead and turn off our definition query if we so desire. Now, one thing that I want to do is let's just go ahead and see if there's any statistically significant clusters of crime events inside of the city. And we can go ahead and do that by going to the Analysis tab, and we can go to our geoprocessing gallery here, and we can expand that out. And notice how we have all of these pattern tools here. And I'm going to go ahead and select density-based clustering. And that's going to bring open the density-based clustering tool. And what I'm going to do is I'm going to select my crime incidence layer. And it's going to go ahead and default to a nice default output name. We'll go ahead and leave that the same. And then we have a variety of different clustering methods that we can select. In this case, I'm going to select dbScan, which is definitely one of the faster ones that exists out there. And I'm going to go ahead and specify how many minimum features per cluster I want to see and what the search distance is. So, and let's say I want to see everything that has around at least 10 features per cluster. And then as far as the search radius goes, let's just go ahead and say within 100 meters. All right, one of the nice things that they did at 2.8 was introduce the ability to do this based on time as well. In this case, we're not going to use the time option because that will increase the processing time just a little bit. But with that, I'm just going to quickly review it one more time, and then I'm just going to go ahead and hit run. This tool will take a little bit to run, and once it's done, it's going to output a nice new layer onto our map that highlights all the different clusters that might exist in there. So there we go. And as you can kind of see, we have a lot of different, we do have some clusters. And let's see actually if our existing arson falls into any of those existing clusters. And actually, one of our arson events is actually quite near some existing clusters. Oops. Now that we kind of understand it, we can kind of see where some of these clusters are, we can actually follow this up and start to look at these different clusters, and we might even want to do things like we can join this to our existing data. So one of the nice things about this is it does give us the source object ID, so we can go ahead and add a join in here so we can see those events, what they might be. So in this case, let's just go ahead and add a quick join. Actually, I'm going to make sure I select the correct layer. There we go. Oops. Source ID. To object ID. We'll go ahead and hit 1. And it's going to go ahead and add in all this so we can actually start to explore what some of these clusters actually represent. And then, as we saw with our previous exploration of the data inside the data engineering view, a lot of these are going to be thefts or some sort of robberies or something along those lines. But what we can actually do now is we can go through and take a look at our crime incidents one last time. And what we want to do is we want to turn on the time on this layer so we can turn it into a timeline. So in order to do that, all you have to do is just right click and go to time properties, and it'll bring up this window. And then we can select each feature has a single time field. And since we did that conversion to a date field in the data engineering view a couple minutes ago, it automatically detects that. And then all we have to do is just hit OK. So now the layer is time enabled. We can tell because there's the time slider up here. And what we can do is we can go ahead and then right click again and go add to new timeline. It's going to throw you a little bit of warning because there is quite a few features inside of here, so we just want to accept that. And what it's going to do is it's going to go ahead and add in our data to a timeline. It's going to take a couple seconds to load here. And then while that's loading, we can go ahead and go down here to the layer. We can right click on go to the properties for our layer that's in the timeline. And then what we can do is we can specify the display field and the category field. And what this will allow us to do is this will allow us to split the timeline into specific lanes based upon our crime. So we want to see how our arson compares against, say, the timeline of other crimes. And we're just going to go ahead and hit OK. And let that load. And once that's done loading, what we're going to do is we're going to go up here to the diagram tab, and then we're just going to go ahead and enable lanes. And then show the lane names. Let's just explode. Let's just move this up just a little bit. All right, so now we have our data in a timeline. And now what we can do is, since this is fully connected to the map, what we can do is say we want to select our arson. What we can do is we can just highlight it on there and it'll highlight it inside of our map. Or say that we wanted to take a look at this time cluster of burglaries and maybe see if they're in the same area, and no, they're kind of spread throughout the city. But notice how there is a gap there, another gap here. And really this is made available, and we can actually kind of detect these patterns using the timeline itself. So with that, I'm going to go ahead and turn it over to Tony, who's going to show you a little bit more on some other ways that you can incorporate things like movement analysis and some of the cellular data analysis to really help further and understand your investigation.
Today we are going to go over workflows and procedures that are useful as an investigation tool. We will step into the role of a police analyst with the goal of providing information that can support officers and detectives in producing leads for 2 instances of arson that occurred on the same day. We will be looking at mobile track data and the relationship that each device has with others in the dataset. Another dataset is the incident data from the area in Washington, D.C. This data has had the location and attributes edited for the purpose of this demonstration, but it is representative of the original data. We're going to explore the mobile track data and look at the relationship in conjunction with the incident data. The first thing we will do is check the movement data for spatial temporal matches when compared to the incident data. To prepare the data, we need to query out the arson cases using the definition query. To do this, right-click on the incident layer and select Build Definition Query. Click the New Query button to build a new query. We will use the Query Builder, which is the default tool that appears. Select from the drop-down menus and set them to Offense is equal to Arson. This will remove all the records that do not have arson as the offense from the view. The data is still there, and if we need to remove the query, it will be visible again. We will now run the buffer tool to provide an area to analyze based off of the points that represent arson events. From the Analysis tab, click the Tools button to bring up the geoprocessing pane. From the search bar, we will enter Buffer and select the Buffer tool. For the buffer, we will use the Crime Incidents layer. Give it a name of Arson Incident Buffer. The distance will be linear units, 50 for the value, and meters for the units of measure. Leave the method as planar and dissolve type as no dissolve, and run the tool. The next tool requires our layers to be time enabled. This is done to identify a field or fields in the data that represents the date and/or time that corresponds to each feature in a layer. Doing this is done by right-clicking on the layer from the Contents pane and selecting the Time properties. We will time enable the Movement Tracks layer first. Set Time layer to each feature has a single field, and set the Time field to Date. Click OK to enable the time. Open the Time properties for the Arson Incidents Buffer. Set the Layer Time option to each field has a single time field up. Then select the time field and set it to report_date and click OK. We will now run the Compare Areas tool. This will look at the tracks and determine which, if any, of the tracks entered the buffered area within the given time frame that we provide. From the Analysis tab, expand the Geoprocessing Gallery. Under the Movement section, click the Compare Areas tool. For the Input Point feature, select the Movement Tracks layer. The Input Area feature will be the Arson Incidents Buffer layer. Leave the names as the default of Movement Tracks Compare Areas. we need to identify the field that contains the unique identifying value in the record. For the point field, that will be the dev_ID field. And for the area field, it will be the CCN field. Now, we can check the relationship for location alone or location and time together. We will be using location and time to determine if any of our tracks were in the area when the fire was reported. Set the time difference to 1 hour and run the tool. The best way to look at the results of the Compare Areas tool is to put it in a link chart to make it easier to visualize the relationships. From the Analysis tab, we will create a new link chart. We will add the first entity by clicking the Entity Types button from the Link Chart Diagram tab. For the layer, we will select the Movement Tracks layer. The entity field will be the dev_ID field. Name this entity type People and click OK. Add another entity type, and this time we will use the Arson Incidents Buffer layer. The entity field will be the CCN field. We will name this entity type Arson Events. Now we will add the relationship between the two using the output from the Compare Areas tool. Click the Relationship Type button and set the People entity as the source and the Arson Events as the target. We will use Compare Areas as the name of this relationship type. Use the drop-down menu to set the key type to Foreign. This will allow us to use a source that was not used in the original entity creation as our relationship source. Choose the Compare Areas output for the layer. We will now set our key fields for the source and the target. These will be used to create a linking field from our source data to our foreign data. We will set the key field to dev_ID for the source, and the target key field will be CCN. The last two options choose the field that contain the same value from the foreign layer. The track ID field has the value of the dev_ID field, so that will be our source, and the area ID field contains the same values as the CCN field from the Arson buffers, so that matches our target key field. Click OK to load the relationship. The link chart is zoomed out very far at this point and hard to see anything. We will enable our filtering to remove anything that doesn't have at least one link using the Filter Links from the ribbon. Click the box beside the minimum and set the value to 1. Click Zoom to Extent and you can now see the 3 relationships that were generated from the Compare Areas tool. The link chart is now showing us what entities were linked to the arson areas within 1 hour of when the arsons were reported. This will become a key focus on our analysis as we move forward because of the temporal and spatial proximity to when the fire could have started. The next step will be to analyze the movement data set and determine relationships between each individual from our movement data set to the others. We will use the Find Meeting Locations tool to check for spatial and temporal overlaps from each individual in our movement track dataset to all the others in the dataset. This will evaluate each individual's location and compare it to others and determine if 2 or more individuals were within a given distance from each other for a minimum amount of time. From the Analysis tab, expand the Geoprocessing Gallery and under the Movement section, select the Find Meeting Locations tool. The movement tracks will be the input feature. Use the default names for the output. Set the dev_ID field as the name value. Set the search distance to 100 meters and the minimum loiter time to 1 minute and run the tool. This will give us all possible times where one value was within 100 meters of another for 1 minute or more. Now we will add that output to the existing link chart. To do this, activate the link chart if it is not already your active view. From the Link Chart Diagram tab, click the Relationship Type button. Now set the source and the target both to the people entity. This is because we'll be creating a relationship that links the people together based on the output of the Find Meeting Locations tool. Now name this relationship Meetings. Set the key type to Foreign and the foreign key layer to the meeting details output from the Find Meeting Locations tool. Set the source key field as dev ID and the target key field as dev ID, since we will be linking the same entity to itself. The matching source key field will be participant 1, and the matching target key field should be set to participant 2. And click OK. We will now change the layout of the link chart to organic. This will help to visually clean up the link chart now that there's more links in it. Since we want to focus on the arson events, we will open the Arson Incidents Buffer Layer attribute table and select all the records in that table, and it will also select all the records in the link chart that were derived from them. We will then use the Select Connected to add to the selection all of the entities that are directly connected to the arson events. The Select Connected button is located on the Link Chart Diagram tab. Each time you select Connected, you will add one level of connected entities from your original selection. We will use the Select Connected button 3 times, and then we will change the selected layout by going back to the Change Layout and choosing Clustered. Then we will use the Zoom to feature to zoom into our arson events and connected entities. The last thing we will cover is adding call record data to the link chart. We have a simple call record that has had the numbers edited for this demonstration. We can add this to the map as a table by going to the Geoprocessing pane and searching Excel to Table. Fill out the input as the Excel file, name the table for the output, and choose a sheet to be imported and run the tool. Going back to the link chart, we can add this to help build a better picture for investigators. Click the Add Relationship button from the link chart ribbon. Choose people as the source and target to link these based off of the calls. Name the relationship CDR for call details record and give it a label as call. Choose foreign as the key type, and in the layer, choose the new CDR table. Dev ID is going to be the source key field and the target key field. The matching source key field is going to be the transmitting number, and the matching target key field is going to be the receiving number. Click OK to build the links. By selecting the CDR entity from the Contents pane and clicking the Symbology button, we can quickly change the color to help differentiate the meetings from the calls in the link chart. We now have some people that are connected to the arson areas based on space and time, and some that are shown to have at least been in close proximity to those individuals. One individual has been in contact with one person from each arson event. This list of connected entities should now be given to investigating officers for action and follow-up.
Thanks for that rundown, Tony and James. That was great. What I want to do now is bring in Jared Bostic and bring Tony back in here, one of our product engineers. And want to go from demo to sort of what happens out in the real world. So Jared, we've got a couple of questions we want to ask you. And first, maybe just a couple simple questions about your Fusion Center, what you guys do, and then maybe some more in-depth questions about ideas on how to deploy Pro Intel. So first off, tell us a little about the Alabama Fusion Center, some of the operational mission components, and who actually makes up the Fusion Center.
Sure. Thanks, Carl, for having me. So here in Alabama, we only have one Fusion Center for our state. I know a lot of the states, specifically Texas, has multiple Fusion Centers, but here in Alabama, we just have the one. So with that being said, our center is an intelligence unit that's hosted at the Alabama Law Enforcement Agency. And what it kind of makes up of is it's an all crimes, all hazards Fusion Center. So we support any type of criminal activity cases, any type of efforts for public safety, even large scale event support, whether it's, a NASCAR event or whether it's, a large college football at Alabama or at Auburn. So we provide support for that as well. Within our Fusion Center, so we have a missing persons unit. We have people assigned to the missing persons unit. We have individuals who focus on the strategic intel side of things, looking at patterns of crimes, trends, analysis, supporting human trafficking. We have individuals assigned to the gang unit, narcotics unit, and then we also look at the domestic and international terrorism perspective as well. And then we also have finally some individuals who look at the tactical support side. So whether it's supporting a murder case or any type of real-time reactionary support for something that's happening right now.
Great, thank you. And maybe just quickly share a little bit more on some of the who exactly makes up the Fusion Center, from the different agencies as well as the different roles within those agencies.
Sure. So, within the Alabama Law Enforcement Agency, we support the State Bureau of Investigations, any type of homicide. We support external agencies, whether it's the Attorney General's office. So our reach is far and wide. So our analyst here within, we work with a lot of the local law enforcement perspective as well. So supporting those local law enforcement is one of our largest reaches.
And then the role of the analyst and some of the activities GIS has played a major part in. Could you walk through some of that?
Yeah, so here within the center, our analysts are using GIS on a daily basis. I know a lot of the analysts, I'm sure a lot of the analysts on the calls are using PenLink for cell phone records. Our analysts are using our software, the Esri platform, for looking at cell phone records as well. Our missing persons unit. We have instances where we might have a child reported missing, or a senior alert goes off. So we utilize the platform for looking at time and distance trends, how far somebody could potentially travel within a certain amount of time, since the person went missing, or how far somebody could potentially walk. For an Alzheimer's patient, they left their home and we're searching for them. How far could they potentially walk? Here internally also, our analysts focus on the school safety side. So it's a governor initiative that's been assigned to our Fusion Center. So we have a couple analysts that focus on any type of threat towards a school, looking at the social media side, but then also analyzing any type of call that might come in from a local law enforcement perspective. And then, that being said, GIS, like I was saying, does play a major role in our Fusion Center, looking at, analyzing a lot of the data, looking at the trends and patterns of crime, the different types of threats most common, and then finally, taking all that information and then kind of and ingesting that into the GIS platform, looking at link charts, and all the analysis that you can do within the Pro Intel platform.
Great, and you guys have done something different than most agencies, most centers. You have your GIS is hosted in a CGIS compliant cloud. Tell us a little bit about that, what that is, what that means, and why you guys did that.
Yeah, so we hosted or stood up our instance of Enterprise, ArcGIS Enterprise, within the Microsoft Azure environment. It's the GovCloud environment. Due to the sensitive data and material that we deal with, PII, CGIS data, we did go through the steps of making it a CGIS compliant environment. So we went through all that, but not my focus, but where I am, here within the organization, our GIS shop is within the information technology unit. And what that allows us to do is work directly with a lot of the IT personnel who are dealing with, data consumption from all the law enforcement agencies around the state, and we're able to work with them to stand up services. And so we have a direct link to our information technology unit. But where I physically sit is actually just outside the Fusion Center itself. So having that direct contact with the Fusion Center allows us to have that real-time information come in, and the analysts have access to the GIS unit right here outside their door.
Great, and one of the things that Tony and James showed was the sort of the scale down menu and button options for intelligence analysts that use GIS rather than GIS analysts that may be trying to do an intelligence function. Tony, maybe if you could go into a couple questions about some of the more specific Pro Intel tools for Jared.
Yeah, so with the compare areas tool, that was one of the ones we saw in the video where it compares movement tracks, and you can add the temporal component to it to determine if there was any overlap in a defined AOI. Is that something that you've used or would use in past or future cases?
Yeah, so honestly, it's probably something we've used several times throughout the years, specifically related to missing persons. Looking at those cell phone records, where that individual that went missing, where the last known location of their cell phone was, but then taking into account the known suspects that we are looking at those cell phones, whether it's 4 people, 5 people, 10 people that could be involved in a situation. So looking at the cell phone records, tracking where those phones have been pinging, looking at the towers, where any type of overlap might be for those cell phones. So really trying to identify if somebody would have been in the same area based on time and where that overlap might be. So having that, and then also from the field collection standpoint, having our officers and investigative technicians out in the field giving that real-time information where a investigation might have taken place. So we're not doing any type of overlap, so we know where our people have been.
Okay. The other one was we didn't see this one in the demo, but it's classify movement events. So what that one does is it looks at a movement track data set and compares it chronologically to the other points in the data set. It determines if the track was speeding up, slowing down, stopped, turning left, turning right, that kind of thing. It also determines the speeds of travel if it was traveling. Is that something that you guys have used or would use?
Actually, it has been, and honestly, it's probably been a couple of occasions where this has happened. But specifically, there was an instance where a trooper was involved in an accident with a pedestrian, or not a pedestrian, but a civil person, in their vehicle, and we had to take into account the AVL, or automatic vehicle location data, from their trooper vehicle, and pull it into our GIS system and look at time and distance specifically. So that's been a couple of years. So now it sounds like it does all that for you on the fly, but what I had to do was analyze that data, look at the distance in between the points, try to do the calculation for the time versus distance and look at the rate of speed for how fast that trooper was traveling before impact with the other vehicle.
Yeah, it does it all for you now.
Excellent.
Great. All right. Hey, Jared, thank you very much for joining us. We're going to now proceed on to the Q&A section. I'll ask James Jones to come join us and share his audio and webcam. And we've got about 4 minutes, guys, to go through a handful of questions. The first question is, do you feel that ArcGIS Pro Intelligence is a good tool for entry-level intelligence analysts with limited GIS experience?
That's the goal of Pro Intel is to enable a user who's not familiar with the GPS or GIS capabilities to be able to step in and use GIS in a comfortable and familiar way that's not daunting or intimidating.
All right. And next question is, can you connect Pro Intel to an Azure data lake?
So yes, it's a little bit of an interesting way that you have to do it. You have to technically connect the Azure data lake to an ArcGIS enterprise instance, but then once it's connected to an enterprise instance, you will have access to files that are inside of that data lake. And that not only works not just for Azure data lakes, but things like S3 storage buckets, Azure blob stores. I think there's another one like Alibaba. The Alibaba, similar to a blob store, but there is a way to do it, but you have to do it through ArcGIS Enterprise.
Okay. Is there a way to import Excel spreadsheets listing the names, associations of subjects and businesses to create a lake chart?
Yeah, so what we did there with the call data records at the end of that demo, that's the exact workflow that you would use. You're just going to bring that Excel worksheet in as a table and then build your relationships based off of that.
Okay, and does Pro Intel perform a time conversion for CDRs that are in UTC?
So yes, you can, but you have to use the convert time zone geoprocessing tool to be able to do that, and then you can convert it from whatever time zone you want or whatever time zone you have into whatever time zone you want. So there is a geoprocessing tool that will enable that, and it's the convert time zone tool.
Okay, great. We have a handful of more questions, folks. We're out of time. We're going to respond to you guys directly with some of the questions we were not able to get to, and maybe provide some additional details and URLs for you guys to do your own searches. But that's going to conclude our session today. If you have the time and inclination, there will be a survey that automatically pops up when we close out of the webinar. And then please don't forget, same time next week, we will do doing a similar webinar, ArcGIS Pro Intel webinar, specifically on link analysis. And that concludes our session for today. Thank you for your time and hope to see you soon.
All right, thank you.
Thank you.